Sorry, it is. So you say there are probably going to be errors, and when there is an error at the bottom, you get this small box that says explain error. If you click on it, it opens Gemini, which is what I'm doing on the right hand side. Right? Even if you don't know Python, it'll explain the error, and if you have any coding knowledge, you'll be able to quickly fix errors. Did anyone get it to work? I was able to resolve my errors using Gemini. You have to upload the Excel spreadsheet as well to the to Google Colab.
want me to explain some of the code?
Or you're okay? I mean, it is fairly straightforward, but if you want me to explain, I'm happy to do that. Yeah, so let's. I believe this is data from oil wells. So the date of the date when the data was collected, well bore code means that's the well code. You know, each well has some code. NPD, some other code, some the different types of codes are here, and then stream hours, average downhole pressure, downhole temperature. Unless we see the actual drill wells, it's difficult to correlate these measurements with what's happening in the in these oil wells. This is a publicly available data set. If you search for well bore data set, you'll find it. But you'll see what this is: some pressure, some temperature. I'm not sure what DP tubing is. Let's see, average. I think that's pressure, some choke size, gas volume, water volume, etc. Okay, so this is from a bore well. At this point, we're not trying to build a model. We're just trying to visualize the data and do a little bit of pre-processing. So I mean, understanding the process is perhaps not as essential, but I can try and find the original data set that's available from the. This is also an exercise in finding errors, using Gemini to fixing those errors. Right? It's a new way of coding. If you need help, just raise your hand and I'll see if I can help. Sorry, there's a question. Can you see this? So that's what you have to do. Pip install XLS.
Or you can
I see that some of you have already, you've been able to load the data, get some preliminary information. If you have done that, I would like you to plot the data, okay? We've talked about different ways of plotting data. Not all columns in your Excel spreadsheet make sense for plotting because some of those columns just have the tags for your variables. So pick the columns that make sense, pressures, temperatures, and other variables. Try plotting time series data. Okay. If you don't know Python, you can use Gemini on the side. You can just ask it what you want to do. It'll generate code. Put it in your Python notebook. Once you plot the data, create the correlation map. We talked about time series correlation map. Right? You can also plot the spectral data. Okay. So let's spend 10-15 minutes doing that. Is it working? Good. Thank you. So did you know Python already? Or you know Python? Just Let me know if you finish plotting and finding correlation. You have a question? Sorry? Mat. You can use Matlab. I think it's called Matlab. Yeah. Anything doesn't matter. That's right. Yeah. Yeah. Oh, okay. I can processed. No, that was probably generated by. It must be in your. It says processed, so. Yeah. Do you need a little bit more time, or so you need 10 minutes? Are you done? Use all of them. So find the correlation map between all the variables. Correlation heat map. So you have, I don't know how many, I think there are 14 columns, right? Some of those are tags, so it makes no sense to use tags. But the remaining time series data, probably 8 or 9 variables. Find a correlation plot between those two. You can also plot the scatter plot. Remember we did some scatter plots. Try correlation heat maps and scatter plots. Let me know if you're done, then we can move on to classification. If you need more time, that's okay. We're going to do tomorrow. We will do classification and clustering, and then we will also do an exercise like this on classification and clustering. Right? Yeah. All right, is everyone done? So scatter plot. Okay, so you need 5 minutes, 3-4 minutes. So in the day, they're picking up Python very easy. Are you done? Is everyone done? When we just move on to the next topic. No, I'm actually quite impressed with how fast some of you. Right, right. So, you know, yeah, that sort of raises some philosophical questions for us as educators, right? In my department, for the last 10 years or so, we spent a lot of time, effort, money on integrating Python into all of the courses, with the expectation that when students graduate, they will be well versed with Python, they can be able to. But now, with all of these tools, I'm not so sure. Is coding a core skill that all engineers need to have? The answer to that is not really, because of course coding helps you build a wide range of methods. You learn how to make algorithms, you learn some certain types of critical thinking skills. There are those meta skills that you acquire when you learn how to code, but it's not clear that coding is the only way you can acquire those skills. There are other ways you can solve discipline-specific problems and build those skills. An example is when I was an undergraduate student, we used to have one to do and there was rigorous mathematics we went for very early versions of the work there. But I also learned very good assembly language. So it's a very, very basic foundation language on which you code in terms of hexadecimal. Yeah. You have to do all that. Nobody codes in that language. And then you have C. Python is actually built on C. So, and I have some students who are working in the industry and they have coding that used to take them 2 days, they have to in a matter of a few hours. I think it's still the future of coding. The question is, what skills are you going to use and what can you separate? There are obviously going to be some tests. Nobody's going to code like the way you do. Yeah. I often get is if you want to drive a car from point A to point B, you don't have to understand how the combustion take the car. Because the goal is not to understand complexity. As long as you can drive it. Same with our airplanes, you don't understand what's happening. But you still do that because your goal is something else. Yeah, we still need people who know coding really well. That niche group of computer science students will have to learn coding. Right? But we won't need the same level of coders that we have. In fact, big companies like Microsoft, Facebook, Amazon, Microsoft, we talked about 10,000 people, Facebook, I think is doing similar. Amazon told their employees that in the next 2 years they will reduce their workforce by 20%. Because of our so I think there's a need for this. My son was actually started live school. I don't know how to work, but it's live school. Okay, for a search for it, I don't know if that's what it is, but my son, it's something called live coding. They're always using Gemini, a lot of tools to code. Like
this is grade 7, but he will go for classification on not knowing classification, not knowing math, not knowing algebra, not knowing this. Yeah, it was it's called white coding, right? Yeah, it's a new phrase that people have. It's called white coding. A lot of people are doing it. And as I said, you want to go from point A to point B, you don't have to understand how the combustion is. And we're all working on different research problems, and this is just a wonderful for you to solve something big. You don't have. I remember as a student, I was spending many hours trying to fix the linear forms and measurements in my math lab plots. All of that is not very productive. You have to plot something. You don't have to memorize different lines. You don't have to go and look at the manuals. But some understanding of coding is really useful because these inheritance are not perfect. It comes out human oversight required. So you understand the code, if you understand what it's trying to do, that is certainly good. But you don't have to code.
All right. So in the next 20, 30 minutes or so, I think we have about 25 minutes. I'll introduce classification and clustering algorithms. And tomorrow morning we will, I have some Python notebooks to do this, for example, we'll go to that. So hopefully we'll answer your question for example. I have lots of examples. But today, in the next 20, 25 minutes, I'll just focus on classification. Sorry, is it not on? Okay. Can you hear me now? All right. Yeah, we'll just focus on a couple of approaches to classification, okay? And then tomorrow we will we'll do some of these exercises. So the goal of classification is to separate input data. You have some big data matrix X. You want to separate that into C discrete categories or classes. 1 to C. Yi's are the labels of your data. Each label can take a value between 1 and C. So you have C different classes. That's the assumption. There are many examples I can give you. Model plant mismatch detection. I don't know if you are familiar with that. So typically, when you're running controllers, you want to know when your model deviates from your true process. When that happens, you go back and rebuild your model. Okay, so that's a classification problem. Normal operation versus operation where there is this discrepancy between the model and the true plant. Okay, so that's an example of classification. And you can solve that problem using a tool called support vector machines. We're going to talk about support vector machines. Now there are probably hundreds of different types of classification tools. Obviously, in 5 days, you can't cover all of those. You can't even cover all of those methods in an entire course. There's just so many different ways of doing classification. So the second example is faulty wafers in a semiconductor manufacturing plant, or you will find similar examples in other manufacturing plants. For instance, lithium-ion battery manufacturing. When you're manufacturing something, quality of the product is important. You don't always get the right high-quality product. When the quality is bad, you want to be able to identify that. So that's a classification problem. So you collect your data, and then you want to separate that into normal product and abnormal or faulty product. Can you give me examples of classification, perhaps from your research? Can anybody volunteer? Yeah. Object, how is that a classification problem? Right. Right. So in classification, you have labels. Clustering is where you don't have labels. So classification is a supervised learning problem. Okay. Any other ideas? Any examples from your research? Well. Sorry, identification of. Okay. Right. You want to separate different types of infestations. Okay. Yeah, that's a good classification problem. Anybody else? Other ideas? Classification. Okay. Think about it when you go home. You can you'll probably come up with other ideas. You see, one of my goals is to help you identify these problems when you see them. Right? When you see a classification problem or a clustering problem, hopefully by the end of this workshop, you know that it is a classification problem or something is a clustering problem. Right? If you have labels, you have inputs and outputs or labels, then you can pose. And you have certain, the labels are discrete, and so you just have a few finite labels. Then you have a classification problem. If you don't have any labels, you just have some data, and you're trying to find features in it. Then you have a clustering problem. Yeah. Right. 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 Right, right, yeah. Excellent. Okay, thank you. So classification is what's called a discriminative type of model, which aims to construct these decision boundaries. When you have data, this is two-dimensional data. Often, real data are not two-dimensional. You'll have high-dimensional data. You won't be able to visualize it. But in this case, we have really nice two-dimensional data, and there are three classes. Classification is called a discriminative type of model because our goal really is to find these optimal boundaries between these different classes. You're given the data, and you know that in this case you have, I think, blue, green, and purple classes. You have to find these optimal boundaries between these classes. That's the idea in classification. On the other hand, clustering is a little different. Clustering is a generative type of model, and it aims to find groups or underlying distributions of existing data. There are no labels in clustering. Each cluster maximizes intergroup variation and minimizes intragroup variation. So what does it mean? Now I have here three different clusters. From the perspective of the algorithm, they're all the same. Okay, so visually we can see there are three different clusters. We want the algorithm to identify these clusters from the data. Okay. And typically, when you design these algorithms, what you do is you try to minimize the variance within each cluster. So you want those things to be close, and then you want to maximize the variance between clusters. Which is you maximize intergroup variation, okay, but minimize intragroup variation. Internally, the variance has to be small, and between groups, the variance, you want to be able to separate these clusters to the extent possible, as much as possible. That's why you want to maximize intergroup variation. Okay, so that's the main difference between classification and clustering. So I'm going to show you a simple, very intuitive algorithm for classification. It's called K nearest neighbors algorithm, KNN. It's a supervised classification algorithm that predicts labels of new data. The interesting thing about this algorithm is you really don't need any training. You just load your data and then find the cluster to which it belongs, right? The class labels of new unlabeled samples, we predict that using a procedure. I'll quickly go through this, and in the next slide, I have a nice picture that explains how this is done. You first load all the input samples and the corresponding labeled outputs. This is supervised learning. Remember, we don't just provide X's, but we also provide Y's. You provide the data, the raw data, as well as the corresponding labels. And then specify the number of nearest neighbors, K. K is, what kind of a parameter is that? It's a hyperparameter because it's not your model parameter, it's something that you fix before you execute your algorithm, right? It's something you specify beforehand. And then you also specify a desired distance metrics because you're going to be measuring distance between different data points. You have to have some sort of a metric. In the next slide, I'll show you different types of metrics that are commonly used. And for each new unlabeled sample, okay, so this is all you have to do to execute K nearest neighbors algorithm. You load all your data, load all the labels, determine how many nearest neighbors you want to consider. K, you fix it. Say you fix it to 5 or 10. You also figure out what distance metric you're going to use. And then you load a new unlabeled sample. You find its K nearest neighbors. Okay. K is already fixed. So let's say K is 5. You load your new sample, which is unlabeled. You don't know what label needs to be assigned to it. Then you measure the distance of that sample from K. Say K is 5. Then you measure the distance of that sample from the K nearest neighbors. Okay? And then the label of your new sample, unlabeled new sample, will be the mode or the majority vote of labels of its K nearest neighbors. Okay, so let's say you have 5 nearest neighbors, and 4 of them belong to class 1, 1 of them belongs to class 2, then your new sample belongs to class 1. Right? Okay. So I have a nice picture that illustrates this point more clearly. In just a moment, I'll show that. Okay. So I said there are 2 important things that you have to pick in K nearest neighbors. One is the number of neighbors you want to consider. The other is the distance metric. There are different distance matrices that you can use. Euclidean metrics, which is basically Euclidean distance between 2 data points. There's a 1-norm based metric called Manhattan metric, cosine similarity, etc. We often use the Euclidean metric, but other metrics may be useful in different contexts. I don't know if anybody here knows compressed sensing. Does anyone know what compressed sensing is? Optimization. So in compressed sensing, we use one. Do you know norms? Do you understand when I say a norm, 2 norm, 1 norm? Okay. If you don't understand, let me know. So I can't gauge your comfort with math. So if you don't know norms, you probably are not well versed with linear algebra and the other things. So, but a norm is basically a 2 norm of a vector is defined as follows. If I have a vector x1, x2, x3, then its 2 norm is square root of x1 square plus x2 square plus x3 square. That's the 2 norm. 1 norm is okay, that's 1 norm. So there are different ways in which you can measure these distances. Depending on the problem you have, you'll have to choose the right metric. In most cases, you will likely stick with this Euclidean distance, which is the 2 norm. Okay, so this picture, I really like it because it explains how k nearest neighbors algorithm works. Now I have 2 classes in this problem, blue and pink. Those are the 2 classes. And then I get a new point, new measurement, new data point, which is this x. And I chose k equal to 7, meaning every time I get a new sample, I look at the 7 nearest neighbors of that new sample. Now for this new sample, I have to find the distance between this sample and every other data point in my data set. And then I pick the 7 nearest neighbors. So 1, 2, 3, 4, 5, 6, 7. Those are the 7 nearest neighbors. Out of the 7 nearest neighbors, 4 are in the pink class and 2 are in the blue class. Okay? So what is the likelihood that this new sample is in the blue class, or is it? What do you think? Does it belong to the blue class or the pink? Sorry? Yeah. Right. Is that right? I mean, it looks like pink to me from here. But. All right, right. So red, yeah, because there are five of those, right, and only 2 blue dots, and you classify this as a red dot. That's the k nearest neighbors algorithm. Can you think of any problem with this algorithm? Sorry, yeah. It takes time, yeah. It can get really slow. If you have very high dimensional data and lots of data, if you have big data, right, let's say, this algorithm can take forever. Right? So you'd say you have 1 billion data points. Every time you get a sample, you have to measure the distance of the sample with these, in its naive version, you'll have to measure the distance between every sample and billion other samples in your data set. Right? So that's very slow and ineffective. There are better algorithms for classification than KNN. But KNN is very simple. It's very straightforward. You can code it quite rapidly. Are there any questions? I don't want to start support vector machines today. This requires a little bit of explanation. I want to go through it slowly tomorrow. Support vector machines are a very popular classification algorithm. Okay, so we'll spend time on this, and then we'll spend some time coding tomorrow, k nearest neighbors, as well as support vector machines on some data. So any questions? Do you have any questions? Sorry, what do you mean by hard cluster? I see. So your boundaries are sort of soft. Is that what you mean? Data. Sorry, data that is repeated. I mean, I'm thinking what you're saying is, see, the classification algorithms that I showed here, they have hard boundaries. Can you have a soft boundary, meaning you allow data points can belong to one cluster with a certain probability and another cluster with a certain probability. Is that what you're thinking, or is it something else? No overlapping. Yeah. Okay. Confusing. Yeah. This is we have hard boundaries, right? right? So these clusters are different. Yeah. When there is overlapping, you'll have some false positives, false negatives, and so on. When I talk about support vector machines tomorrow, I'll show you how support vector machines resolve classification between data sets that have some overlapping data points. Sorry, what data? Label data. Yeah, that's right. Yeah. Yeah. Clustering is with that. Right? Is used. Any classification problem. Right? You can use it with any classification problem. You've mentioned a few classification problems. You can use it. Let's see if I have another example. There should be some examples coming up. Right. Right. So that's why we have different types of measures, right? So if you can't measure the distance, you have to, in some form or the other, have to measure the distance, right? Yeah. Because to say that a data point belongs to a certain class, you have to use some measure, right? You have to measure the distance of that data point from your cluster. Otherwise, how do you label new data points if you can't measure the distance? It doesn't have to be Euclidean distance. You have to have some other way of measuring that a given data point is in a certain class or not. Right. Yeah. You can use, fine. Yeah, so I mean that's a good point, right? So it's a thumb. There's no thumb rules, I think. You have to, depending on the number of classes and the dimensionality of the problem, you might want to choose a number. Often what I do is I choose different case and measure the performance, right? If you choose one, your performance is probably going to be bad, right? So as you increase your K, performance will likely get better. But at the same time, you don't want it to become, if your K is 1 million, then it's just going to take forever to solve that problem, right? So you don't want high complexity, and at the same time, you don't want too many errors. If you choose very small K, you're likely to have too many errors. So you have to find that right balance. One way to do that is to try your algorithm with different Ks and see where the sweet spot is. Right. How to calculate? Right. Yeah. Sorry, because of the fan, I can't hear really. Yeah. But that's okay. Yeah. All right. Yeah.
Friday after this session, we have to go to your report. Okay? And Friday we will take our lunch in this one.
guest house or 20 hours. Right.
Group photo will be in the main building. The stairs is there, and we have to go. After taking the group photo, we join the lunch at the guest house.
Today, usually I put the school only. So, both male and non-male, both gentlemen and non-male are there. So, according to Friday after 1 o'clock, we go to the other office.
All right. I'll see you tomorrow. Thank you.
You just go directly to the vehicle and arrange here. And we can to the hospital. One person is telling me about his ISAT being returned.
Sorry? Yeah, I'll find them.
But the lots of other people, much better now. I can never do this is different to taking that out of practice. But very rarely I do money around this. And you want to do sort of applications. say one more goal we have. But having physics, so some physics like getting say you want to work for programming AI or AI, they all if you want to take, like, well, the other, if you want to put an application, you don't need I mean, you don't need the copy. You need copy of these statistics.
What are the kind of physics
what I could do, I don't know if I'm on the project, I would be faculty mostly in the university. So we're all faculty in AI. And then they talk to us sometimes. After this course, you will have you taken any AI courses? Is this your first semester? So all of these concepts will be supervised by Right, right. Yeah. But hopefully this is shedding some light on so I think I expect you to get really comfortable with the machine learning language, like in this language. So you're not going to be intimidated. Then, as a project, you want to find somebody who wants to happen who has interest in that. They tell them, this goes, I have this good understanding of the code. Ask them to find out. You can't do this on your own. You have a contract. And they will work with you, your interests along. They will say they probably need some research. They probably must be like students at IIT, probably very smart. So they go along. But then you find out. You bring your analysis.
So,
10 years ago, you acted like a girl. But now you can understand it. You don't have to write it. If you're developing your own algorithm, it's actually you won't be able to write it. But if it's something standard, then we will do it. You don't have to. As I mentioned earlier, I spent so much time fixing MATLAB figures, right? They don't have the right fonts or right font, boldface, italics, or they are not just and sometimes I don't know formats, if I can do it manual, it's not manual, it's those peripheral activities that are not core to what you do. So I think that's where my code
understanding using it, what do you actually need or for job?
I think it would be good to start with. There's just so much to do. I'm not going to be covering the language model. I'm going to just like that. So the current state of the art is language models. That's what I'm on. So and the field is moving really fast. You have to try and keep up to speed. All the podcasts on the YouTube channel. My best advice I can give you is look up some of your family members. Find somebody who can start. Maybe there are people who need service. If you can bring the problem like this, the AI skills to do it, and they will be I mean, it depends again. If you're good, if you're good at math, you know the very complicated mathematical then you will be fine. A little bit calculus, you'll be fine. You don't know those concepts. Oh, I see. They didn't tell you where, right?
You know how to solve it, but you don't know.
See, that's the problem. That's the problem with all the math programs. That you do math. You don't have the you know how it is. That's just like that. Every job you take out, you invest in that. Everything is about capital. That's why I said at the end of the day. I know it's not a problem. Trying to get out of the problem.
I'm doing that with is it seriously different if you are using algorithms like in the VHS, so it takes time. So is it same and similar to the different ideas if you are using it means after using it in Google Google Colab. So if you are using Chrome, so there also it takes time. So that is interesting, right?
So we use different Google ideas.
The idea is if they are using VS Code and you are performing operations unlike any SER there, so it takes time to get accuracy of query. So is it similar to Google Colab? If they are performing operations there, so it takes time there?
Yeah, that's a good question. Google Colab offers different features. You can increase the RAG. So that's pay for it and use these features, it's what we do with that. A lot of my students stop using their laptops for the research because Google Colab is so much. You can use, say, low GPUs simultaneously, which are laptops like that. You can also increase your RAM and your laptop all the time. So there are advantages to using Google.
It would be useful for
Yeah,
big data sets.
yeah, big data sets. Okay, no problem. All the best.
Okay, I'll see you later. Thank you.